Okay. And I do pretty much cover North America depending on which product groups it is. Today we're going to try to just do a quick overview, and I'd really like to keep this right at the 30 minutes, but then leave a lot of time if there's any questions, anything the group would like to talk about. If on the front screen here, some of the things we're going to go over today, this is kind of a general overview of our different families, is the DX70 is what we call a simple point-to-point system. Then we're also going to talk about this DX80 family here, which is what we call a point-to-multipoint. And then we'll chat a little bit about this Multihop, which actually gives you the capability to add a repeater to the system. And down here at the bottom just basically shows you some of the markets that we're typically in, which is the factory automation, oil and gas, water, wastewater, agricultural, irrigation, and the process world. As far as some of the basics, because we're only at a half an hour, we're going to go over this pretty quickly here, but again, would be happy to talk to anybody offline in more detail. But these are some of the general questions we'll typically get asked when looking at a wireless application. The first one being is, how reliable is the communication going to be? And what you'll find out as we go through this today, we actually have the ability to do a thing called a site survey, which is really just an RF signal strength indicator. And that'll basically tell us we can get from point A to point B. And then underneath the hood, we'll be doing some things called frequency hopping spread spectrum. That is really just part of the technology, the proprietary protocol, which allows us to jump around on that 902 to 928 frequency band. And we'll be going into this in some more detail here. But basically, with what we're doing, we have very robust communications. The other questions that will typically start popping up is, how do I know my data is secure? And as we go through this, what you'll find out, most IT departments and guys are really worried about this 802.11 band, and everything we're going to be doing is a proprietary protocol. So basically, we're not playing on that backbone, which is usually a good thing. Another question that comes up is, how far can I go? And this depends on several parameters, but as I talk about the radios, you'll hear us talk about a 150 milliwatt radio and a 1 watt. And what that means at the end of the day is if you're using a 150 milliwatt radio, we rate those 3 miles line of sight, and that's with the standard 6-inch rubber duck antenna. If we go up to a 1 watt radio, we then rate those 6 miles line of sight. And you can penetrate some floors, some walls. It really depends on what everything's made out of. But going back to that site survey, having the ability to do that will let you know just, how bad your signal's getting hammered if you do have obstructions in between it. Another question that typically comes up is about what happens if I lose my RF link. And the way our system's set up is we have a deterministic system which will allow you to basically predefine what you want the outputs to do. For instance, if it's an analog signal and it's a 4 to 20 or 0 to 20, you can park that at a specific value once you lose the link. As soon as the link is reestablished, it'll come back and everything will go to back to the normal mode. And as far as the radios, we basically have 2 different radios based on the frequencies, the 902 to 928 megahertz and the 2.4 gigahertz. Normally the 2.4 is what we call our global radio because you cannot use the 902 in some areas overseas. So predominantly here in the U.S., I'd say 98% of what we do is the 902 to 928. And you often hear that referred to as a ISM band. It means license-free. Basically anything you're doing with a band or radio does not require a license. And a little quick overview here on the open protocol and proprietary protocol. If you've done some wireless, typically it falls under that 802.11 protocol, and those are things like Bluetooth and Zigbee and some other things you may be doing inside of the plant. And normally you have some type of an encryption key there. When you're dealing with the proprietary protocol that Banner is using is you'll find that we really don't have to have those encryption keys because based on that frequency hopping spread spectrum, our units are linked together and we're not sending any kind of 802.11 packet information. So typically when I've gotten involved in these and we talk to the IT guys, we do have a 3-page security note that goes through all this as they'll look at that, and then typically we get well, you guys are okay, you're playing in your own little sandbox. As far as the radio strength, what I'm showing here on the screen, we'll talk about each one of these, is our standard radio comes with the ability to do a radio signal strength test built within the radio. And what you'll see here is we've exploded the screens here to the right, but basically on the radio, if you wanted to go out and check point A, you would just set your switches here to go talk to that node. Then you would push the button here and it would come up to where it said site. Then you would start getting these screens where the first screen would be 1G and a number. It will then scroll to 1Y and a number. And basically what we're doing at that point is the gateway is sending out 100 data packets to the node. The node is sending them back. And then we're just grading this decibel level that those 100 packets are returning. And we just keep repeating that process until you take it out of this mode. The question always is, you know, what's a good signal? And it really depends on your application. I tend to think of these as bars on your telephone. Some days you've got 4 bars and it's a really good signal. Other days you may only have 2 bars and it's a weaker signal, but you still have a good communication line. The thing that I tend to pay a lot of attention to on this is this multiple resends. What that means to us is the gateway has sent some data packets out, the nodes returned them, and for whatever reason, they may be corrupted, we don't like them, we ask the node to resend those data packets to us. And once they resend the data packets, when this number starts getting up to about 30, it's telling you you're having to request resends for about 30% of the information. So when we're doing this is a good key here to keep an eye on is this missed packets. And often just getting the antennas higher, going to a little higher wattage can solve that. If you have an HMI, we have the capability to come out of here via Modbus, and you could then display this on a screen and look at the green, yellow, red, and multiple resend packets. A third option is with our software now, you can actually pull this up on your laptop and again look at the same information here. Nice thing about this is that if you are out in the plant or in the field and you don't have access to an HMI or a laptop, this site survey is built into all of our radios, which you can do right there locally. And it's very important once you start deploying some of these. As far as this, site survey and how do I get a better signal, often there's a number of antenna options we can do where we can remote mount the antennas here. Typically with the larger antennas, we can go up to about 100 feet on this extension cable. Just keep in mind as you add antennas and you add surge suppressors and you add cables, you do start having some dB loss. But typically increasing the signal, the simplest thing is get the antennas higher. If that doesn't do it, then we just tend to use a little better antenna. All right, I'm waiting on my slide to show. And as far as radios, we're going to be talking about a couple of types here. We do radios with I/O inputs and outputs, and we do serial radios. Today, we're going to spend most of the time talking about the radio with I/O, which would be, analog data, discrete data. And within our radios here, you'll notice a couple of differences here. This is the standard IP67 radio where you basically bring your wiring into here, and inside this radio you'll find a little terminal strip like this that designates where the I/O lands. A lot of customers, once they mount these, they're going to be mounted in an enclosure. So what we also did is we make another version, simply add a C to the end of the part number, and it'll allow these terminals now to be external. So you can now put a little DIN rail mount on this, mount the radio on a panel, and then you can wire here externally without having to go through the radio. Same price, again, just add a C on the part number. And then over to the right here, I've got one of our new Ethernet radios where you'll see the Ethernet connection here, and we'll talk about these, but basically there's two types of radios with I/O or radios where we're just going to be sending serial data. As far as your signal types, we can handle just about anything. You know, discrete I/O, which would be on-off, PNP, dry contact, relays, various analog signals from 0 to 20, 4 to 20, or 0 to 10 volts, thermocouple RTD. We also have some special probes, serial probes that will do temperature, humidity. And then again, we can handle typical RS-485, Modbus, Ethernet, and Modbus TCP signals. We're not going to go into the classified area stuff a lot today because we could do a whole webinar on that. But basically, we have product. The one I'm showing here is one we use in the oil and gas field that will meet the Class 1 Div 1, Class 1 Div 2. We have the certifications. And then over here on the right, I'm showing one of our nodes connected to an Indris Hauser radar unit for doing measuring. But again, if you do have areas where, or applications where it's in a classified area, that's not a problem for us. Power options, when we're talking about power, you'll often hear banner people refer to flex, and that's just our verbiage. When we say flex power, we basically mean battery powered. And as we talk about some of these sensors today, if I pop the lid off of this device here, basically what's in there is a little D-cell lithium-ion battery. If you pop this lid, there's 6 of these guys inside of there. None of this stuff is rechargeable batteries. The only thing that we do that is rechargeable is a solar panel where this battery here is basically mounted down inside of this pole. So as far as dealing with these are, you can go back through distribution, but it's a commercially available battery. Nothing special that you have to come back to Banner for. One of the questions that will always come up is how long will the battery last? And it really depends on a number of parameters. Typically, one of the biggest is the sensor warm-up time and the sample rate. And if we have not run tests with your sensor, you can ship us a sensor and we can characterize that up in our lab. But to give you kind of a quick idea, we do a lot of work with pressure transducers. Those have a fairly quick warm-up time, and often going out and sampling a pressure transducer for a 4 to 20, we can do that every 2 minutes and get a couple of years battery life. If the sensor has a longer warm-up time, it'll significantly hit that. But again, we can check it. Another question that will pop up is about, can you tell me how much battery's left? And really the answer is no. With a lithium-ion technology, that doesn't tend to degrade like with a gel cell over time. It'll just go, and then he'll just quit. So what will typically happen is we'll tell a guy, based on this sensor, you're going to be able to get 2 years. So then they'll PM it and just replace the battery at 1.5 years or a year. One thing we can do, we'll talk about, is we do have what we call a link loss that we can monitor that I'm no longer talking to that node, which some guys will then use that as the battery monitoring. As far as the wireless products, one of the things I just wanted to pop up real quick is all of the software associated with the Banner Wireless is free. We ship it with the units. We put updates on our website. And what it'll allow you to do is some things like I/O linking. You can configure devices. This screen's actually showing where we can go in with the gateway and monitor all 16 of the registers, and then I could pull up nodes or nodes or slaves, depending on your vernacular, and monitor that here as well. And then you can also tie some I/O points and do on-off discrete. The package that we do here is really meant more for setup and debugging. It really isn't to sit there and run like a Wonderware type package. But it does allow you to do a lot of stuff, and it is free. As far as the different families, this is our simplest one. It's called the DX70, and this is what we call a point-to-point. you basically can have one gateway and one node. And what we do at the factory is we pre-map that I/O. A typical I/O structure for these devices is the gateway would have 4 discrete inputs, 4 discrete out, 2 analog in, and 2 analog out. The node would also have 4 discrete in, 4 discrete out, 2 analog in, 2 analog out. And again, this wiring chamber is actually inside the unit. And at the factory, we just pre-map that. So whatever you put on input 1 here is going to turn on whatever you wired to output 1, whether that's discrete or analog. Here's some of the things just to be aware of. With this family, you can only have 1 gateway and 1 node. So if you decide you want to add another node, you have to add another gateway. It really requires 10 to 30 volts DC on the units. These do not play with battery. But what you're looking at here is basically for the pair of these about $950 roughly, and pre-mapped out of the box. So it's a very friendly system that if you're doing wire cable replacement, this is a good one to go. Even though it's somewhat limited, there's really a lot of good applications that it makes a simple solution for. The DX80 family, this is what we now call a point to multi-point or a star topology. And now we can have a gateway, and what he can do is he can now talk up to 47 of these nodes. And the I/O structure doesn't really matter what the node is. We can just go to a total of 47 of those. With this family, now we can start doing a lot of the flex power or battery things with small modules or solar panel. The other big advantage is you now pick up the capability to pull Modbus RTU out of the gateway. And Modbus RTU is what we use as kind of our resident serial package. If you want to do Modbus TCP or Ethernet IP, it is just a different gateway. We call it Gateway Pro, but it looks identical. To give you a rough idea of pricing within this family, you're looking at a $719 for a gateway, $719 for a node. So you're running at about $1,500 versus $1,000 for the DX70. But now you have a lot more options here of adding battery power, I/O, and a lot of different analog to it. The only caveat I want to bring up here is if you're doing the Class 1 Div 1 or Class 1 Div 2 stuff, the only thing that we have set up for that now are the 150 milliwatt radios. And we are working on classifications for the 1 watt, but when you see DX80 performance, that now is pretty much our standard radio, and that comes with a 1 watt capability or a 1/4 watt, which is switch selectable. The Multihop family is the only family that we do that gives you now repeater capability. And within the Multihop system, these are all individual radios, and there's a dip switch where you can set it up as a master, a slave, or a repeater within the same radio. The only caveat is now this system really requires you to provide a Modbus master. With that DX Performance family, it does all of that kind of under the hood and keeps life simple. The Multihop allows you more flexibility in a repeater, but now you really need to be able to hook a Modbus master to basically run this network. And what we can do now are things like this where you might have buildings or you could have terrain that's going to block the signal. This system will get around that, and it will basically self-form so that when you set up the radios and turn the master on, he'll go out and determine which ones are set up here as repeaters and which ones are slaves. So the slaves will try to find the simplest way to get back here to the master radio. So these guys would basically hook on to this repeater. This guy may hook on here. And if this repeater fails, these two guys will go into a self-healing mode, and they will try to find another way to self-heal and get back to here. So Multihop is a great network. It's just if you're comfortable dealing with data registers, you'll find this fairly simple to use. If you aren't comfortable with data registers, I've got another trick we'll show you towards the end of here where we can actually integrate the Multihop with the performance and really give you the best of both worlds. As far as our board level products here, what we've done is we've had some customers that have wanted to embed this into a panel or a smaller device, and we've basically taken the internal radios, put them on a board level. you drop down to about a $300 price tag, but you also lose about half of your I/O here. So these may or may not fit your application. Again, talking and working with a C&E guy will best be able to determine, where does a board level product, fit best for you. What I was showing here with this screenshot is on the performance nodes, and this could be gateway or any of our devices. If you go to the Banner website and go to the wireless area, what you'll see is we'll break down and show you the actual model of the nodes, the frequency of the radio. But here's really the nice thing in this area. It will show you what the I/O structure of that radio is. For instance, this one has 2 discrete inputs, 2 thermistors, 2 outputs, a couple of analogs. This one down here, I've got 4 discrete in, 2 analog in. So if you go to the website and look at the nodes, whether it's the DX80 or the Performance or the Multihop, it'll show you this breakout and kind of give you a really good idea of what kind of I/O structure you've got. A product we introduced about 6 months ago is this little Q45 family. And if you've used some of our photoelectrics, you'll notice it's the same package. What we did is we basically put a radio in here with a couple of batteries, and within the family now there are 4 sensors where we can do a couple of discrete inputs. We can do a convergent photoelectric, a fiber optic, and then a retro where you wanted to look at a reflector. This family, because the antenna is internal, it'll give you about a 3,000 foot range from the node here to the gateway. And let me kind of flip here. Whenever we do this family, we pre-map this at the factory. So if you ordered these sensors, this gateway has actually got 6 discrete outputs on it. So whenever you set this up as node 1, that one is automatically mapped to output 1. Node 2 is mapped to output 2, 3 to 3, and on and on. And you do have the capability to go in there and change that mapping, but this makes it simple to take it out of the box and get going. You also have Modbus capability here, so if you have more than 6 outputs, you can put up to 47 units out there, and then look at your registers via Modbus. We also are showing a board level for this gateway, and what makes this system nice is we can do some little inexpensive things now where I can take one of these nodes and have a couple of discrete inputs, go to a gateway that is 256. So I can now, for about $500, do a 2 discrete in, 2 discrete out with this family. The RD unit that I brought up is really handy in that what it basically is here is a node with 2 discrete inputs, and there's a connector here where you can have a field wireable or one of our QD cables, and then when you come off the end of the cable, you basically have discrete input 1, discrete input 2 feeding into this guy. So if you have any applications out there, we've looked at some overload relay monitoring. When the relay hits, they just want to wirelessly send that signal out. It makes it a real nice way to deal with wireless in that $500 area now, where maybe it wouldn't make sense to try to do that for $1,500. Let's now kind of go into applications here. This is where people tend to like the most, and I'll kind of go through these, and then we'll just go ahead and unmute and open this thing up. Here's a typical application that we run into pretty much daily now, where someone has conduit going from the control building out to the tanks, and the conduit gets water in it, and they're forced with peeling this up. Basically, you could put a node out here with 3 inputs to it, pick up all 3 tanks, put a gateway back here in your control building, and for $1,000, $1,500, it saves you redoing the conduit and the wiring and peeling up the sod and the cement. So that conduit wire replacement is one that we do a lot. This is a really good application for that lower end DX70 that we talked about at the front end of the webinar. Tank monitoring is another good one. This is one we're showing with an ultrasonic sensor up at the top of the tank, basically looking down, reporting back level on an analog signal. And then out on the tank, you would have a node with a battery module, and again, an ultrasonic sensor here. To give you an idea about that battery life, the QT50 is a larger ultrasonic sensor that will do about a 28-foot range. And if we put this out on the tank, sample that analog value every 15 minutes, we'll get about 5 years out of the battery, basically driving this whole setup here. One of my rule of thumbs with flex power is only use it when you have to. Anytime you introduce a battery into the situation, it's just another maintenance issue. And all of our flex power units come with the capability that if you did have power there, you can actually disconnect the battery and run 10 to 30 volts to it and do either battery or DC supplied power. But take level is one that we do a lot of. And again, depending on your sensor, this could be pressure sensor, could be an ultrasonic. We can do a characterization test that'll tell you how long the battery on that will last. Here's a little application that we did that we couldn't actually use the real pictures, but it shows a node here with a push button and an operator, and then they show another device here on this unit being powered by the battery on board. So when this guy is basically ready to transfer this pallet, he hits a button, it goes out, lets the AGV know, and it comes and picks up the pallet. So AGVs has been a pretty standard application we do a lot. Here's a robotic application, again, where you've got a battery, you've got a node here, and then you're going out and picking up I/O on the end effector. A couple of cautions here is when you're dealing with speed on the wireless, you'll see things like 65 milliseconds. My rule of thumb is that if something happens, give us a second. If you need it quicker than that, then we really need to look at the application. There are some things we can do in the sub 100 millisecond, but that gets to be a slippery slope. If you've got a second to see I/O change, then typically we don't have to worry. But that's just a rule of thumb I use. And again, when you're doing a battery, the more sensors you start adding to this, the quicker you're going to run that battery down. But picking up I/O on the end effector is a good app. We've also got guys using that new little Q45 that we just showed you because, again, that's less cost, and they may just be picking up a couple of points. Here's a project we did with a transfer press, and this was basically just monitoring some vacuum sensors. That was an analog signal, and if the signal got below a certain point, they wanted to come over, shut this down. This was a good test for us because the devices here were around a lot of noise in this particular area right here, and worked out really well. One thing here to be cautious of, you'll notice the gateway got mounted inside of an electrical control box with the antenna, and it worked. But really what you're going to want to do is if you're going to mount any wireless radio inside of a metal box, you're going to want to run an extension cable to a bulkhead fitting and then put the antenna on the outside of the enclosure. If it's a fiberglass enclosure, typically we're okay. That doesn't degrade the sound or the RF very much. But if it's a metal box, you really want to get this antenna outside the application. Here's another AGV app for Pokeyoke that we couldn't take pictures of, but worked out to be a really nice application where this AGV would pull into an area, and at this point there was a sensor in the floor and the node was mounted on the AGV. Once the sensor detected it, our gateway would disable the node, and there was a little push button here that until 3 processes got done to this, the operator could hit the push button, but the vehicle would not leave the station until the gateway verified that process 1, 2, 3 was done. Once we completed that, the gateway basically sent a signal, said re-enable the relay. The guy could hit the push button, then it could go to the next station. Motor temperature is a really good one. With our standard nodes, you'll find these, some have 3 thermocouple inputs, some had 4. We can also do RTD. Play very well with the flex-powered battery. Since the thermocouples really don't pull much power, you could put a node out here with a battery module, and this guy would probably run 5 to 7 years on that battery. Some applications, the guys will come down with a thermocouple on the flange of the motor or a certain part. Another one we do is, this is a T-gauge, which Banner manufactures. This is basically an infrared sensor where it's looking down because the shaft's rotating. There's really no way to stick a thermocouple on that. So another way to do temperature applications is with this Banner T-gauge, and we can get that with a discrete output or with an analog output. The emergency eye wash, this is one that's becoming very common for us, where somebody has an eye wash station or shower. If this gets activated, they basically want to give a heads up to security. So we can put a node in here with a battery, run a discrete input. A lot of guys are actually putting flow sensors in line. What I'm showing over here to the right is, early on we had the separate battery module with a node. With another family we've got now, you can actually get the node where the battery is actually part, so now you've only got one piece. And we still have both versions. It just really depends on if you want to do a plug-unplug battery or pop the top off and keep it into one piece. Again, if you have applications on this, let us know. We've got a full PowerPoint going through all the ANSI requirements for this application, and we've got several of them on the books. This was a detention pond monitoring where the company had these detention ponds where they had all the runoff from the roof and the parking lots here, and there were ponds at various locations around the facility. What we have got inside this box, again, is just a node with a battery, and then we've got a 4 to 20 milliamp transducer going out into the water. Whenever the level gets to a certain point, the radio will transmit up here. This pages a guy to come in, and then they can release this water into a little stream that's back here behind it. If the water goes over top of this, because there's a polypropylene liner, it can generate EPA issues that now they've got to deal with, but if they release the water, then they're okay. So the detention ponds with a simple 4 to 20, again, this one was sampled every 2 minutes, and we're getting about 2 years of battery life on that guy. Another field retrofit for people doing water, wastewater, and I think we had a couple of guys on board today. This was a Hach SC Controller, and this was a digester at a plant, and they basically were looking at dissolved oxygen and some different measurements coming from here back into this. And then once this was mounted, the customer wanted to pick one analog signal off here and run it to a maintenance building that was about a quarter-mile away. So this was a real simple application to add a node, run the analog input into the node. We then map it to the gateway, and it's now showing up a quarter-mile away in the maintenance shed. Here's another outdoor monitoring, level monitoring, where we use one of our solar panels in a setup. And we basically have a 4 to 20 transducer in the water, which is coming up. We're using the node with the battery here. Also, we've added the solar panel because they wanted to do this in a Modbus mode, which basically at the end of the day pulls more power than the 4 to 20 signal. So this is being picked up here, and then back in the administrative area, they've got an HMI that is just reporting back temperature, pressure, level, and then a little bar graph on the level. Rapid deployment, we do a lot of this where they want to take an enclosure, add some kind of a probe, go put these in areas, pull all of my signals back, to my gateway. This one happened to be in a semi-trailer where they had an Allen Bradley, and we were just collecting the analog data, coming back to here, and they would do that every 30 days, take it down and go back and redo it. As you're dealing with different probes out there, we've done a lot of work with a company called In-Situ, but there's a number of people doing these level probes. In-Situ happens to have one that does Modbus and analog, and what we're showing here is one of these probes. We can come out of it with 2 wires to one of our serial radios, and then come back and basically pull all the data out of the registers internally on that probe. Again, just some other screens we did for them where they had different probes. They wanted to go look at different information. And C&E does a lot of HMI work. And with our radios and the Modbus and Ethernet, it makes it very easy to go out and collect your data and get it back into this kind of a format. Door monitoring, this is one that's popped up now with that new little Q45 we talked about early on. This is the discrete sensor here, and what this customer did is basically mounted that in a box, came down to a little reed switch with a magnet. These happen to be Honeywell. It then goes back to a central control panel that any door that's open pops up in red, any that are closed in blue. And this is one where we ended up that, we said this has only got about a 3,000 foot range. They had multiple buildings on this, and what I did is we put together a hybrid system here that kind of makes a nice thing to talk about. And what we can do with these data radios is I can have these little nodes out here with a gateway. We can then take what we call a data radio, and if you remember that the data radio is just a 232/485 serial radio. The gateway will collect all of this information, and then we can take a splitter cable and come from the data radio to here. And all he's doing is this radio is looking at his Modbus registers and then transmitting it. What's kind of neat here is this little family is a 2.4 gigahertz so that it can be sold globally. Well, this is now that multi-hop family we talked about with the 1 watt radio. So what I'm doing is taking this little nest here, collecting his information, and now putting it up on this 1 watt repeater 900 megahertz backbone. And what the HMI is simply showing here is with my master radio, if you go out and toggle sensor A on this network, that'll show up. If you go toggle sensor A on this network, you'll see an indicator light come on. So if you do have applications where you're limited by the 3,000 foot range, this is a nice setup. And if you have other applications where you may have DX80 stuff out here, we can basically pick up that little network, put it on the multi-hop, and this is just kind of an advanced way, but it works really nice. New products. This is a new Ethernet data radio that we just introduced, basically as a Cat5 cable replacement. Anywhere you're running cable, you should be able to put this radio on one end, this radio on the other, and it just becomes a transparent cable for you for Ethernet information. C&E Lunch-n-Learns, if any of this stuff makes sense and you would like to have a lunch-and-learn, we do a little 1 hour overview where we'll come in and bring the hardware, provide lunch, and if you coordinate that with C&E, I'd be happy to get involved in those with you. And I think at this time, I'm going to see if I can unmute everybody here. And if we've got any questions, I'll be happy to hang around as long as anybody likes. Okay, can everybody hear me okay?
Yeah, Terry, I've got a couple of questions. This is Chris Bramlett.
Yeah, Chris.
On the QT50, the ultrasonic app, I know that ultrasonics draw a lot of power. Was that a single battery or was that a 6 battery pack module?
No, that's actually the single D-cell battery. And the reason we can get that, because we make that ultrasonic sensor, we can actually go in and tweak the circuitry. But to give you an idea, that sensor, it has a 500 millisecond warm-up time. So from the time that we basically turn it up, wake it up, and say, hey, take your reading, it only takes 500 milliseconds for us to get a good analog value. When you get to dealing with some of these radar units, like I showed you at the front end with that Indris Hauser, those have a 29-second warm-up time. And really going from 500 milliseconds to a 1-second warm-up time could cost you as much as 6 months on a battery.
Wow. The second question I had is you had a application picture of one of the devices attached to a welding robot.
Yep.
Knowing that both welding and servo motors generate a huge amount of electrical noise, how is that communication on that system?
Well, typically what I'll do there is I'll put it in and I'll look at that site survey. If you see a lot of missed packets coming back, it tells you, I may not be able to tell you what the noise is if it's from the welder or what, but you'll see a lot of missed packages. It just says, hey, I'm having to resend this a lot, which is noise. But on the one that I did where we did the gateway, it was coming back to the node, and we were just sending a couple of discrete and a couple of analog I/O points out of there, but we were actually powering up the node at that point.
Okay, but it handled the noise okay.
Yeah, and that's where I use that multiple resends. When you're doing these site surveys, particularly things like RF drives are real noisy and can throw out a lot of junk. Is if I put it on there and that missed packet information is really low, it tells me I'm not getting hit. And by doing that 902 to 928, I really didn't have time to go into that. We do that thing called frequency hopping. And what happens is once these guys are kind of wired, or what we call bound, they start jumping frequencies thousands of times a second. So if something's getting hammered at 908, as soon as they jump, they'll pick that information up on the next jump or the next hop.
Thanks, Terry.
Any other questions, guys? All right, CB, you want to call the dogs in, or?
You betcha. Thanks for your time, Terry.
All right, man. See you.
Have a great day.